Welcome to episode 12 of Human Factors in Design. I'm Joseph Giacomin, and today I will be discussing displays. In a previous talk, we had discussed controls at an interface being how we get some information into some sort of a product, a system, or a service, how we tell it what we want, how we make choices, how we ask it for things. So we talked previously about issues involved with how we control a device or request things from it or interact with it. Now we're going to talk about the other way around. How does the product, the system, or the service tell us the response? How does it tell us what's going on? How does it tell us, inform us about its situation? So communications, exchanges, interactions are a two-way street. There's what has to go in from us, and there's what has to come back in a form and a format that we as humans can understand. So today we'll just talk a little bit about displays or display systems. We'll clarify a few definitions, and you will probably notice right away that there's a certain parallel or symmetry with respect to many or most of the things we said previously for the controls. There's a lot of similarity between the logic we take into the design of a display with respect to the logic we had adopted for the control. So first of all, let's be clear what we're referring to. From a human factors ergonomic point of view, this is not technology. We're not going to talk about the machine itself, whether it's mechanical, electrical, what principles it uses. We're going to talk about displays in terms of what they look like to us and what they mean to us. And from that point of view, there's three approximate categories we tend to talk a lot about in design: quantitative, qualitative, and situation awareness. The names are fairly self-explanatory. Quantitative means probably there's some numbers and some mathematics somehow implicitly involved. Qualitative is going to probably be something about a state or a condition, possibly indicated by a word, a name, maybe a color, something that tells us that something is either present or it's not present. And situation awareness, very related to cognitive workload that we had discussed previously. Situation awareness are all those display systems which give us more than one type of information usually, because the objective of a situation awareness display is not to tell you about one particular thing. It's to try to inform you about the general situation that's going on. In an aircraft, it's about the general situation of flight of the aircraft. Are you flying in an area where there's other airplanes? Is your fuel load sufficient and safe to get you to destination? What are the air temperature and other conditions affecting the plane? Are all the aircraft systems operating according to plan? Situation awareness is really about giving you an overview of all the things you're interested in to do a certain task or to do a certain job. So displays, quantitative, the world is full of them. It doesn't matter whether it's an old-fashioned machine or a modern cell phone. You're familiar with lots of displays. There's analog displays with needles and pointers and changes of colors. There's digital displays with numbers or pictograms or other things on them. There's a wide range. Some are rotational in nature, similar to a clock. Some are linear sliders. Others are combinations. The point is here, there's some numbers involved. It's expected that you're paying attention to the numbers that are being displayed. Instead, qualitative displays follow a different logic, and we're not so concerned about the numbers. Are you really worried when you're driving your car whether the coolant temperature in the engine is 100 degrees centigrade or 90 degrees centigrade or 60 degrees centigrade? is that really something as a driver you're thinking a lot about and you're keen on? Or do you just want to know the engine's okay and the coolant temperature is average normal or still a bit on the cold side, or oh, for heaven's sake, it's heating over and we're going to break the engine if we don't turn it off and let it cool down? States or conditions tend to be more the thing of interest to people, and qualitative displays work on that principle. Here there's two rotary examples, one a full circle, one a semicircle, and you can see that the engine or coolant temperature is indicated as a cold zone in yellow, a normal zone in green, and a warm zone in red. So these are just telling you things are okay, not yet in the best okay, or there's a potential issue occurring and there's a problem coming up. Many machines, from mechanical devices like road vehicles all the way to computers, laptops, and cell phones, over the last 100-200 years, many machines started out with very technical display systems with numbers designed by experts in technical matters, engineers and scientists, assuming that the operators needed or at least wanted these numbers. But as time progresses, in most types of product or system or service, you see a migration or a shift from what starts out rather technical, quite often involving at least some numbers, and then slowly tends to be something more like this, which is some conditions rather than some numbers, because conditions or metaphors are important to people. Numbers can be important or not, depending on the person and the context. So something like a sports car 50 years ago would have been full the dashboard or the instrument cluster with instruments reading numbers. Today it is usually just a little light that changes color to warn you if something unusual has happened. The third type of display is information situation awareness display. The radar operator screen, as used at an airport or a military base, or the radar as part of the avionics of the aircraft itself. That's an excellent example of a situation awareness. You can see here what's going on in the picture. The gentleman is monitoring some traffic. He has some symbols or some little dots or some sort of an indication on the radar screen of where various aircraft are in relation to him and his airport. He can usually, with a modern system, click on a dot or click on something that's connected to the dot, and can then look at things such as the number of the flight. Oftentimes they can see things like the fuel loading or the number of passengers or some other parameter, which in the past would have been just available to the pilots on board. But with modern systems and modern digital communications, quite often we can get where it is, how fast it's flying, some indications about fuel and passengers and other things that might be affecting the aircraft, and we can get, as the radar operator, a very complete understanding of the spatial and temporal, space and time, situation of all these aircraft that are in the airspace. So situation awareness display is a slightly different concept. It's wider and more complicated and much more cognitive than are the other two types. Now, in terms of rules of display design, there's various standards, there's various guidelines in different fields, such as people make cell phones, people make automobiles, people make home appliances like the washer machine. There's a variation in what people attempt to achieve and what's considered good practice. However, there are some generic rules of thumb which come through in most product systems and services, and these are four of the bigger ones. You can find resources with other possibilities in further detail, but these four tend to be rather general and generic and need to be kept in mind by designers. So 4 fundamental rules of display design. Present the information in a manner that if something is wrong, you know it right away. Information displays are often part of safety critical systems. You really need to be able to spot with very little effort and without much cognitive processing when something goes awry. Display only the information which is adequate for the job. As we'll see in a few minutes, over the years, most product systems and services that maybe started out a bit complicated have been benefiting from continuous simplification of their systems and their interfaces, because there's a recognition that human beings can only take on so much cognitive workload, only have so much perceptual capabilities. Simplifying the display such that whatever it is it was supposed to do is very obvious to the person without much effort. That is something that in all fields, in all designs, creeps in eventually into the product, system, or services. Display only as much detail of information or to the right accuracy that's needed for the job. If I'm driving my car, do I need really to know that the temperature of the coolant is 90.03325 degrees centigrade? Is that a level of accuracy which is fundamental to the task of driving a car? Your response, of course, would probably be no, and I would agree with you. The information not only needs to be as simple as possible, but the detail, the technical scientific accuracy should be kept to the minimum necessary, because anything more than that implies that you as the operator, as the human, should be worried about these other digits of numbers that are being presented to you. It implies that it's useful and it's needed, and it might lead you to worrying or thinking or being concerned with matters which are of no particular relevance to the task. So keeping it to the minimum accuracy is also fundamental from a human point of view, not from a computer point of view. Computers can deal with relatively large numbers without too much extra need for electricity and resources, but humans, our information processing capability, as we've seen many times, from Fitts' law with motion to some of the things we discussed in cognition and cognitive psychology, human abilities to deal with information are somewhat limited, and we need to not request too much. And then finally, present the information in the most understandable way possible. Avoid a tiny font. Don't clutter the display with irrelevant things. Provide information, not decoration. As designers, we often have a tendency to put a lot of aesthetics and consider quite a bit the aesthetics of what we're designing as a product, system, or service. Quite often that can run a bit, and we might have a display or a screen or a menu which is visually more complex and more decorative than it needs to be, and that is to the detriment of getting across in a simple and direct manner the actual information that's needed. So, examples of these. Many examples could be provided. I'm only going to provide one or two for each of these four targets or objectives of display design. Failure or malfunction. In the good old days, when all indicators and displays tended to be mechanical, or when we were talking about the first early cathode ray displays, such as was used on radar or what was used on television and so forth, quite often one manner of making sure that a malfunction would not be missed by the operator was to line things up. If you take a look at these examples, you can see that in each of them, several of the displays have their needle lining up on some number, and the numbers could be different. Maybe one of the displays has got a temperature and the needle's on 30 degrees. The other one maybe has an air pressure and maybe it's on a certain number of pascals. They could be talking about, informing about different things, but the point is, in the normal operating condition, when you're running the mechanical or electrical device in its normal mode of operation and you're interacting and in theory everything is fine, the needles line up. If one of the indicators drops down or pops up, you can see all three examples show at least one doing that. When that occurs, it means that that particular measurement, that particular channel, the pressure of valve number 310 at the nuclear power plant, that particular sensor, that particular channel that's being displayed on that display has deviated from what the designers expected it to normally do. So as an operator, when you see one of the indicators deviating out of line with respect to all the others around it, you immediately go check it. And you immediately go see what the problem is before it gets out of hand. So in the olden days, visual alignment was one technique for making malfunction or failure extremely visible and evident to people, even when they weren't paying that close of attention to the display. Failure malfunction is also traditionally indicated by uses of colors such as red color, the red zone on your RPM meter on your car, the red zone on the pressure valve of the submarine. There's always a red strip indicating when you're now reaching values which should be considered problematic and need some attention and some checking. So the use of colors and indications on the display or on the dial itself or on the pressure gauge is another traditional approach to making a malfunction very visible. Colors are also a traditional tool of the trade. Doesn't need much discussion. You're familiar with the fact as a stereotype and as a metaphor that green usually means it's okay, everything's fine, or move or go. Yellow is a transition state. Red means there could be something starting that's worrisome, that needs checking. And a flashing red light is always indicating there's probably an emergency underway. Why do we use flashing or blinking for the light and not just the red color? Apart from issues of color blindness and color defects, the flashing activates, if you recall the talk about human vision and the eye, the flashing activates the rods which are all around the periphery on the inside of the eye. So if we use just color, which is just processed by the fovea, the tiny little area, a person might not notice for sure that it's red unless they're looking straight on at it on the optic axis. By flashing and blinking, we can be looking that way talking to someone, and our rods, which are off the optic axis to one side, will notice the change in light intensity from the blink. We'll pick it up and I'll turn back and say, what's wrong? Something is blinking here. So blinking is a fundamental design tool for attracting attention. That's why your turn signals, your yellow turn signals on a car have to blink. That's why emergency lights on any kind of equipment blink. That's why when something didn't work right on the internet portal, when you were trying to buy something from Amazon, the warning message blinked. It's to attract your rods and to make sure your attention is drawn to that particular event. Now, in terms of one of the other of the design targets, one of the design considerations for displays, essential for adequate job performance. Make sure you're only giving enough information to do the job and not lots and lots of extra, possibly irrelevant facts. Well, this is a little diagram taken from a book treating aviation avionics. We have the year on the x-axis across the horizontal, and we have the number of displays rotary dials, pressure gauges, blinking lights, whatever, any type of display that was in the cockpit on the panel of these aircraft. The little the dots or the data points are different aircraft. And I think you can see the pattern. We started with the very first aircraft having only a small number of informations, but as we add more complexity to the engines and more complexity to the aeronautical controls via flaps, ailerons, and so forth, as we start to add more hydraulics for the landing gear, temperature control, air pressure in the cabin, filtration of air, etc., we start to have a huge number of displays. And you can see very quickly in the 1940s and 50s how quickly the number of things being shown to the pilot, the co-pilot, increased. As a matter of fact, the early aircraft in that period had a pilot, a co-pilot, and usually what was referred to in English language as a flight engineer. There were so many things to check and so much going on that they had a person there just to look after the engines and the mechanicals and the hydraulics, following the gauges and the pressures and the readings. But you can see that as it became more and more complex and these displays multiplied, it became more and more frequent in the cabin, it started to get to the point where people were overwhelmed. By the time you get to the Boeing 747 jumbo jet or the Lockheed or the Concorde, you're starting to have situations where even 2 or 3 pilots are not always in full awareness of everything that was being displayed everywhere around them on their panels. So then computers come along in the 1970s and the 1980s. They start to become powerful, they start to become cheap, RAM chips and so forth drop in price, and we start to integrate computer systems where the computer monitors multiple measures, multiple sensors, multiple situations, and maybe just gives us one little indication that it's okay or not okay, with all of the many sensors and the many mechanical and electrical issues, the actual numbers in the background hidden from the pilot. So we start to see displays where lots of things are simplified and we can get rid of a few instruments that way. And then we have menu systems where we can toggle from one thing to another. So at any one time, we don't have too much on display. But if we really have a concern for some reason, we can go dig that out from the system and request it to bring it up if we really want it, and so forth and so on. And we start to see avionic design very much driven by cognitive workload and situation awareness considerations, where we remove many things, we simplify others, we put on multiple menus and multiple options the others, and we start to bring the complexity down so that the pilots can focus a little bit more on the actual flying of the plane and not always checking all of its many, many hundreds and hundreds of parameters. So essential for the job, just what you need to fly the plane, is of course the main target today. And you see the same trend in road vehicles, whether it be automobiles or lorries. You see similar trends with rail transport. You see it with all kinds of complex systems. You see it with software and apps. Not too many apps today have hundreds of menu options. The menus are restricted and simplified because we're only presenting what's adequate and needed for the job performance. In terms of accuracy, the third of the recommendations, in terms of the accuracy required, surprisingly, simplifications are being found all the time, and not all of them are fully intuitive, because assumptions were made when these systems were first developed about what was required, but over time we might come to realize that the way people think and the human thinking pattern that arises when they're doing something with whatever it was we designed can be very different from what's natural to the machine itself. The machine talks its language, has its characteristics, but people quite often think very differently and would benefit from very different things. One very nice example of that is this one here, which is, I think it was referred to as digital wire. We have, in almost every car in the parking lot back here, we have a navigator these days, a screen with a map, with arrows. We discussed in a previous talk the design and the excellent design of the TomTom navigator in the 1990s. Those devices are very good and they work very well, and the ones that talk to us and interact through the vocal channel simplify a lot of things, and they're very natural and they're very good systems. However, they are still based on assumptions which may not always be necessary. For example, a navigator which shows my car as an arrow on a map is taking as the metaphor a paper map. And it's the arrow is taking as a metaphor something like a video game or something where an arrow is superimposed on a map. Now, that is clearly usable, it's clearly familiar to people, there's nothing wrong with it, but is that really the only way, or put differently, is that definitely the best way to show a person where to go when they're actually driving the car? If I'm sitting in my living room planning the trip, I guess the map probably is the best way to look at things and figure things out. But when I'm actually driving, is a map on a screen that I have to keep looking at and deviating my eye glance and my attention off the road, is that really the best way to do it? And it may prove in the future that it wasn't. And one example of a recent technology which begins to look at the opportunities to change that metaphor is this one here, where an overhead cable, a virtual heads-up display projected onto the windscreen cable, is shown in real time to indicate to you where to go. So I typed into the navigator I needed to get somewhere. When we get to this junction, the one showed in the image, the navigator knows it needs to tell me to go left. The navigator could put a great big arrow with a little left-hand hook and then tell me by voice, like a friend might tell me if they're reading the map, you really need to turn left at 50 meters ahead when you get to that junction. That's one way to do it. It works. It's fine. However, this is another way. Maybe if I'm the driver, I don't need the navigator to talk to me or show me arrows or project maps onto a screen that I need to look at. Maybe I could just follow through the window, a big finger in the sky showing me where to go. Maybe that's a lot easier, even though it's new, it's different, and it wasn't possible when we had paper maps and we didn't have computers like today. But as a metaphor, it may turn out to actually be easier with less requirements of cognitive workload. Who knows? It may even turn out to be a bit safer. We'll see in the future. And then finally, simple, direct, understandable, one of the 4 display requirements. Already in the early 20th century, the phrase became popular in the United States and in the English language, a picture's worth 1,000 words. The origin of that statement is usually attributed to Brisbane, who was a newspaper editor in the United States, when he said to one of his colleagues, use a picture, it's worth 1,000 words. This statement, though, is a deep truth, which has been known to people for a long time. It wasn't just that 1911 when they first recognized it. But the fact of the matter is, imagery, whether in art or photography or in graphic design, imagery is incredibly powerful because text language, natural language, needs areas of the brain, it needs processings which are much more recent in evolutionary terms. Humans develop language much later than our brains develop the ability to see shapes, to identify things in the environment, and to recognize that, those 3 rocks all look the same, those 3 animals are all of the same type. Our ability to process visual images is much more ancient, much deeper in our neural machinery, and it's much more efficient than are the machineries we use for language. So Simple, direct, and understandable, quite often in design terms, translates into I wonder if I can convey this with an image, particularly a picture, because it's going to say so much more than what I can achieve with a number or with some words. And I think if you look at the picture that's there on the right, there's so much that can be said about that person, what they're feeling, the circumstance, what's causing the problem, what kind of weather, what kind of place the person finds themselves when the car broke down, so forth. Trying to convey that by words and numbers would not do it justice. It would take a lot of words, a lot of numbers, and it may not fully convey what's really going on in this complex scene. Images are very powerful. And images, quite often in design terms and in human factors ergonomics practice, we end up quite often talking about logos and symbols. Logos for businesses and activities, symbols for safety critical and other items of information which are more standardized. When it comes to something like a symbol to use on a display, there's a wide range of symbols in actual use. The symbols all originate from one of three possible approaches. One approach is what you see here on the left, which is physical similarity. So if the thing is new and there is no standard, there is no background, the people don't have any experience yet with the thing, we can certainly take a picture of something or draw an image of something that resembles it to a degree, and we can use that shape and that image to say something, maybe add some words to it, and we'll capture the physical similarity, and hopefully that will translate into people's minds to recognizing the artifact. Another second of the three possibilities is convention. If we all agree that the stop sign is red, when I see the red sign in the distance, even before I can read the word stop, I will know that that means stop. So there are things in society we've all agreed is a good thing, we should all do a certain thing, we should all use this symbol to say a certain fixed idea that everyone recognizes and needs to respect. Those established conventions, quite often put in law by governments, that's another approach to creating symbols, and that can be more arbitrary. I can choose any image I want for certain ideas that I want to put a sign on the street. As long as it's announced, it's coded, it's established a convention and communicated to everybody, that then is a perfectly usable symbol. And then finally, the third approach to coming up with visual imagery and symbols that are of relevance and can be understood by people is metaphor. As we discussed in a previous talk, explaining something that may be new or unfamiliar or complicated by means of referring to something more familiar, maybe less new, and possibly even simpler. So here you can see the metaphor. If we're going to put a big logo or a big symbol on the charger, the charging point on the street at the curb, where a person can go with their electric car and recharge the batteries, and this is a recent design issue, what symbol or what image are we going to put on the charger such that everyone knows that particular column that's on the curb is a charger? It's not a pillar box for the post. It's not something about what the company is doing, who's in that building over there. How are we going to come up with a symbol that everyone's going to recognize is an electric charger, when an electric charger is a relatively recent development which few people have actually used so far? Well, here you can see metaphor being put to perfectly good design use. If the fuel pump for the petrol and the diesel that we've all been familiar with for over 100 years, if that has a certain shape, and all the symbols in all the manuals of all the vehicles on the road, in all the books, in the highway traffic code and so forth, if all the symbols that have been in use for a long time show that, Maybe if we put the letters EV, electric vehicle, onto the picture of something we associate with fuel and energy, maybe it'll work as the logo or the icon or the symbol that we can put onto the side of the charger pillar and have people recognize and identify quickly without getting confused. So metaphor, you can see here that the petrol pump has been the model, the mental model used for symbols for the diesel pump. Looks the same, just a big D to distinguish it. And now it's being used also in many places for the electric vehicle charger when scientifically, physically, practically, there's no connection between pumping petrol, which is a liquid, into a tank of a vehicle and connecting an electric cable and transferring electrons of electricity across from the mains or some source over to a battery pack in an electric vehicle. We're talking about two scientifically distinct processes that don't resemble each other very much at all, except for the fact there has to be a place where you can hook up to it. But in people's minds, it might be thought of with a similar metaphor because it's always energy. It's always a form of fuel to some degree. So we're using the visual metaphor that was well established with a little tweaking and adjusting to represent the new thing. And this issue of symbols, icons, logos, what is the best visual simplification to represent something, is a continuous evolving activity in design. It's something that never ends because new technologies come online, new lifestyles emerge. We're constantly updating, extending, sophisticating the things we're already doing. Now, in this example that's shown in this slide, we have an example from, I believe, the 1980s. At the time, the very first automatic tire inflation system was put into commercial sale. Renault, the French company Renault, put into production for the very first time for an automobile an automated system to keep the tires inflated. So if one of the four tires would lose a bit of air for some reason due to a puncture, a leak, or some other difficulty, the system had sensors in the rim, and it had a air line which went through the center of the hub and could reach the rim, and automatically a compressor would pump some air into the tires, which was a very, very complicated matter because wheels turn. So managing to make a coupling which doesn't leak air and can pump air in was a very complicated mechanical design. But anyway, Renault came out with a new technology, helpful, important. Flat tires are very bad problems. Low inflated tires are incredibly dangerous. When you go around the turn, you can roll the tire off the rim and flip the car over. So a new technology to address an important issue. Now the question then became, how would the driver know it's working? So you get in the car in the morning, you sit down, you pull your seatbelt, you turn the key, everything starts and you're ready to go. How do you know it's working? What if the system malfunctioned? If the system malfunctioned, you might have a tire that's leaking and you now might be in a dangerous situation. You go down the road with an underinflated tire, all kinds of bad things can happen. So there was a need, whenever you introduce a new technological function, there's also a need to communicate it and communicate its operating state to people. So there was a study done back in the 1980s when these systems first came into play, and the study was looking at how should we inform the people? What kind of little symbol should we put on the instrument cluster of the car? And this was a study by the US Department of Transport because they wished to standardize the symbol and tell all the vehicle manufacturers to use the same one. What little picture should we put on the little block that lights up on the instrument cluster such that when that thing lights up red, you know there's a problem with the tire inflation system, and therefore you need to check your own tires manually because potentially there could be a flat one and it could be dangerous. So they tried sending out a questionnaire to a few thousand people, if I recall correctly, and the questionnaire had a whole battery of symbols and it had a whole battery of explanations in words, and they were trying to match and see how much the people associated the system that we're talking about, tire pressure inflation, with the various symbols that could have been used to represent it in the car. And amongst the symbols there was the existing ones, the International Standards Organization ISO K11, and there was the ISO K10, which had been developed for other purposes related to defective tires or tire pressure problems occurring for different reasons, not in relation to the inflation system, but they look a lot like what we're trying to tell people about. So they said maybe we can use the existing K11 or the K10. They also added to this questionnaire a battery of new symbols which they developed for the occasion. One of them is the one you see towards the bottom of a vehicle with one of its tires colored in to give you the feeling that one of the four, something may have changed or something's not right. And then the final one at the bottom, of course, looks a lot like a picture, and a picture's worth 1,000 words. The one at the bottom, with most people, you'd expect them to understand something's probably wrong with the tire. And when they sent out the questionnaires and got back the responses and analyzed the data, what they found was the somewhat abstract, not completely obvious K11, the one at the top, only 25% of the people ticked on the box that described the system that they were trying to represent. The K10, which has clearly a cross-section of a tire with a big alarm exclamation point in the middle, that sort of made a bit more sense to more people. It was closer to people's understanding of the possibilities. That one, though, still only had about 38% of the people, less than half. The vehicle with one of its tires colored in, that one did much better, 81%, but practically 100% of this several thousand people indicated the bottom image as clearly telling them that one of the tires was probably underinflated, which was probably due to the failure of the inflation system. So what does this tell us? It tells us that every time we introduce something new, we have to go back and look and see if we have the right tools in terms of existing icons, symbols, labels, existing imagery to do the job. We have to check if anything's changed in the people's understanding of the existing ones, and quite often, as in this case, it's necessary to come up with a new symbol or a new icon to inform the user that something with this new technology is happening. So it's an ongoing process in human factors, ergonomics, and design to continuously review and update iconography for telling people things. And if you just look at, for example, the developments with emojis, which are being used as a form of communication between people, you can see they're routinely updated to represent new values and new ideas in society. They're routinely, regularly changed in terms of their graphics as we come to realize that some things look better or more appropriate than others. So this is a form of communication, and all forms of communication are in continuous evolution. One final example of simple, direct, and understandable is the issue of what's referred to as the packing factor, the display packing factor. As a general, simple consideration, any type of information we're trying to present would be easier if the display visual is relatively sparse or relatively empty. As we put more and more information, whether they be pictures, numbers, or words, onto the screen, finding the relevant one and understanding it quickly becomes harder and harder. And here we have a diagram which along the x-axis on the horizontal we have the packing factor, where the packing factor is defined simply as how much percent of the screen, let's say of the computer, how much of the computer screen is occupied by letters, numbers, words, pictures, and how much of it is blank space. Okay, and the blank space is considered where there's a little box, a little square where there's nothing in it. So the blank within an X is part of the X, but the blank where there's nothing written in the whole region would be considered blank space. So you can see on the right we have examples of a screen where there's lots of stuff printed, a bunch of X's in this case, just to give the example. 30% density, 50% density, 70% density. I think it's clear and straightforward what we're talking about. X-axis is that packing density, and on the Y-axis there's the mean time to find some relevant item from within that. So if we had a test where we present one of these screens and instead of those X's there were some words or some pictures or some numbers on the screen, and we said, do you see the word cat amongst the many words on the screen? The y-axis here is the amount of time it would take to find and say yes or no, there is the word cat or there isn't the word cat on the screen at the moment. And as you can see, the amount of time goes dramatically, exponentially up after we get to about 40-50% packing factor. So if all the other considerations were met and done well, we still have a question of we cannot put too much information, particularly of different types, on the display at the same point in time, because otherwise you hit this problem in finding it, decoding it, using it, and responding. And then there's considerations for displays about view angles. Quite often it's very easy in design to focus on the interface, focus on the screen, focus on the buttons, the lights, and whatever is involved in the interaction, and then forget that a person has to see these things. So there is a question of, if I put all this on the computer screen, at what height might the table be? And does my laptop computer permit me in any way to change that? Because these viewing angles are incredibly important. They're important towards seeing clearly the display and the information, and they're also important, as we discussed in a previous talk, for the comfort. If I have to bend my neck downwards for a long period of time, or slightly upwards for a long period of time, I very rapidly develop neck strain. So looking at the whole operator station and how the display system, or whatever it is, the product system or service, how it might be placed within that environment, that's an important thing to give some thought to it from a design perspective as well. Now, in terms of design classics, I'm just going to talk about two because they're very good illustrations of display considerations. The first one is the very traditional, typical automobile, but many machines have similar displays, analog speedometer. We all see out in the parking lot that to this day, 80, 90 years later, cars still tend to have a speedometer with a needle rotating around a circle on which the numbers are printed. And if it's not mechanical anymore, and many cars are not mechanical anymore, there's not a cable connected to something on the drive shaft, but if it's not mechanical and it's electrical, still doesn't change the fact that the computer screen, which is placed in the instrument cluster on the car, or on the lorry, or on the aircraft, still is imitating or emulating a traditional analog needle chasing around a rotary dial. Why is this? Why is it that after 100 years we're still using the exact same system? Well, from a display point of view, this particular instrument does a pretty good job on all four of the key criteria. I'm only displaying the speed to a scientific accuracy, which is the minimum necessary. Failure conditions are obvious to see. If I'm going too fast, there'll be a red zone over there. If I'm grinding to a halt because something cut out, I'll see the needle going towards zero. It's a very the rotary motion matches well the visual acuity of the eye. I can see, if you recall, fractions of a degree of angle are easily resolvable by the visual acuity of the human eye. We had discussed that previously. So the rotary motion, I can see even very tiny differences in the angular position. It's an easy thing for the human eye to pick up. So it matches all those sort of human factors considerations we've discussed up to now. But there's also another fascinating consideration here, which is it's not just showing you the velocity or the speed. It's not just reading 20, 40, 60, 80, 100. It's also showing you how quick it's going up or going down. When you follow with your eye the needle, and as we said, you can follow it very accurately, the rotary motion, as you see the needle moving, the speed of the needle is the derivative, for those of you of an engineering or scientific persuasion, the position is the speed or the velocity. If I talk about instead not where the needle is currently pointed, but how fast it's moving to the next position, the speed of the needle changing, that's the first derivative of that information. So if the information was the speed or velocity, how much the needle changes is the first derivative of the velocity, which is the acceleration. So this instrument matches a whole set of human visual abilities very well, and it's also giving you a lot of bang for the buck. It's giving you 2 items of information for the price of 1. You see the speed of the car, the velocity at that point in time, and how fast the needle is moving up, meaning speeding up, or how fast the needle is moving down, slowing down, is the acceleration of the vehicle. You're getting both speed and acceleration simultaneously and very naturally and easily. So the analog speedometer and all the many manifestations of this sort of display, which are used in all kinds of situations, in all kinds of machines, is an incredibly compact, efficient, and natural way of giving information to people, and that's why it's still in use in some form after more than 100 years of use. And finally, as another design classic, we have Google. What you're seeing here on this slide is the original Google homepage from 1999, the beta version when it first went live. I think you can see, if you think about the packing factor, the packing density that we discussed a few minutes ago, if you think about some of the things we said about the 4 design criteria, keep it to a minimum, keep it simple, make failure obvious, I think something like this, a white box with the name Google, so you know who's doing it and who to thank for it, and just a little text box to type in and say, go for it, find it. It's hard to imagine taking away anything further to simplify the interface. This is about the minimum, the absolute minimum that's achievable. So here we have an excellent example from a design perspective, and this was part of the success of Google. It's not only the efficiency of the algorithm, it's also the naturalness with which the search operation can be performed by people. Here we have an interface where you want to find something, you only know a couple words, there's no point showing you lots of extra information or suggesting dozens of other things you could do. Type it in and we'll see what we find. And there's no point putting advertising or lots of other things on the screen because you're here to find some website or some information. You're not interested in anything but that. So there's the box to type it in. I'll see what I can do. Google is an excellent example, the homepage of a design display which meets all the main criteria. And to this day, it's slightly more complicated. They put a few pictures for fun, but it's still a relatively good example of a clean, simple, nicely reduced design classic, design interface. You can see the work of designers and design in play on this particular interface. So we'll stop there. I thank you once again for your time and patience. I think this program of talks has come to an end. I hope that over the 12 talks there have been some items of information that can prove useful to you in your work, in your daily activity. And I thank you once again, and goodbye.